Okay, welcome to COP1334, Introduction to C++. My name is Professor Lusby, and I thought I'd make a tutorial video here on one of your latest assignments, the fraction calculator. And I have the requirements right here. They're pretty close to what you guys need to do. And the assignment was a fraction calculator. And the whole point here is to be able to allow the user to perform arithmetic operations on fractions. These include the primary four operations: add, subtract, multiply, and divide. And this assumes that we can input the numerator and the denominator of each fraction separately. And so given the numerator and the denominators of each fraction, we should be able to come up with the resultant numerator and the resultant denominator. But they are very specific in that our program must consist of at least these following functions. One of them is a menu function that's going to inform the user about the program's purpose, explain how to enter data, and allow the user to select the operation. Another one, we want to be able to add fractions using an add fractions function. Of course, we have subtract functions, multiply functions, fractions. Add fractions, subtract fractions, multiply fractions, and divide fractions. And here's a sample of what our output should look like if we were to, let's say, input 3 as the first numerator, input 4 as the second, as the first denominator, 2 is the second numerator, 5 is the second denominator. Here's the answer once the correct mathematical operations are performed. We should get something like 23 over 20, and it basically notes that we do not need to have our answer in lowest terms. So if it can be simplified, we don't have to worry about that. All right, so with that said, what I'm really looking for here is that you guys can create a program that's divided up into several methods or functions here. This is really important in the real world. There's a bazillion reasons why, but one of the main reasons is for maintainability and testability of your program, right? We can always create every program in the real world using one big main function, but it's going to be really ugly. It's going to be really hard to maintain. It's going to be really hard to test. So that's why we need to be able to do these things called functions. So with that said, let's go ahead and dive in here. And this video, what I want to dedicate this video to is creating the pseudocode for this particular program. Okay, and typically what I do is I create pseudocode in my actual integration development environment, aka Visual Studio, for this class. And this is because if you do this, you can basically leave the comments in your code, leave the pseudocode inside of your actual CPP file, and then you can actually put actual code underneath of the pseudocode. So I'm going to go ahead and start a new project here. Everybody at this point should know how to create a project by this point. I'm going to give it a simple name like fraction calculator because I'm not very original here. And go ahead and click on OK. And we should see in a second the project appear on the left-hand side under what's called the Solution Explorer. And you're going to notice that there's no source files, there's no actual files created yet because we just created an empty project. So I'm going to go ahead and add a new source file, just a main CPP file here, and go ahead and add that to the project. And in this way, once we open up main, we can go ahead and we can start writing our program. Now, what I want to caution against is what I've seen a lot of beginning programmers do is they start writing code immediately without thinking about the design, without thinking about the pseudocode, and you're going to see as you get more and more complex programs that this isn't really going to be an option anymore. Okay, so the first thing that you really want to do here is at least at a bare minimum come up with pseudocode. What would be better is to actually use some UML diagrams to actually look at your code at a high level using graphical representations, so that, well, one reason is just so you can explain it to your fellow software engineers a lot easier, right? A picture's worth 1,000 words, okay? And any UML diagram should map directly to code, but I'm not going to go there. So basically, in this lesson right here, I'm just going to talk about the pseudocode for this particular problem. Now let's go back. Let's look at the problem description again. We want a fraction calculator. Okay, this is what we always want to do. We want to kind of back up a second, look at the requirements, right? These are our requirements here. We want a fraction calculator that basically has a menu function and these four main functions for the actual math logic. Okay, so we know we need at least 5 functions, and it seems like we're going to be calling this menu function to display a menu, and then we're going to be calling one of these particular functions based on what it is the user actually wants to do. Do they want to add fractions? Do they want to subtract fractions? Etc. So, this document, these requirements give us a really good feel as far as what the user wants. All right. So with that said, we may be referring back to those quote-unquote requirements quite frequently. What we want to do first is, what I want us to do is get into a good habit. I know I've been kind of lenient on this throughout the semester, but at least include a header at the top of your file, stating what the file name is, what the project name is, maybe a description, who was involved in writing the code, the date, and this just gives people who maintain your code later on a good idea of, well, who originated the code, so that if they have any questions, they can always ask them. And you know what? There's some companies that have even more information, like the actual versioning information, as far as when bugs were fixed and which particular bugs are fixed. Do some research and find out the really good types of things that you want to put into your file header. But definitely get used to putting in a file header into each one of your programs. Now, what I want to do now is we really want to start looking at, let's say, our main function. Well, before we do that, let's just go ahead and type in our basic framework for a C++ program, right? We always typically, for our projects in this class, always use IOStream for the CN and the cout operations, so I'll go ahead and include those. Okay, using namespace standard, so we don't have to put standard every time we use CN and cout. We'll go ahead and put that, and then let's just go ahead and do our nifty little void main function that every program has to have. Okay, and maybe I'll blow this up a little bit more so that make it easier to read for you at home. All right, so this is our basic framework for any C++ program. The next thing we need to do is what a lot of us aren't doing enough of, and what I haven't really done enough of during class, which is really think about the pseudocode. Think about the code behind the scenes, and also let's think about commenting the code. I know I haven't really, I've been pressed for time, so I haven't really been commenting the code. I want to make sure that I really do that here. So the first thing that we want to do is, yeah, we have this main function, okay, but now let's actually include some code that talks about what it does, okay? And all you really have to say for the main function is, hey, this is the main module, this is the starting point of the program, right? Every program starts with main, okay? That's just the de facto standard of every program. Is there's a main somewhere behind the scenes that is basically calling all of the other code. There's not, the computer doesn't randomly execute code. It always starts with main. Okay, of which in main, keep in mind that every function, every program has input, process, and output. For this particular program, when we say input and output, we're not saying in general. Okay, what we're saying is, for main, is there any input needed from the outside world to have this program work? And the answer is no. We're actually going to ask for the different numerators, for the denominators, for the operation inside the program. We don't need any input from the outside world in order to have this program work. So for input, we're going to put none. For the process, what are we going to actually do with this fraction calculator program? Well, we're going to display the menu. We're going to process a menu request, and we're going to display results. How do I know that? That's basically from the requirements here, right? It lets us know that we're going to perform arithmetic operations on fractions, and then it says that our sample output needs to look like that. So the short version of that is we're going to display a menu, we're going to process a menu request, and then we're going to display the results. The output, we don't really need, outside of this program, we don't need to pass any output. Could we? Sure. Yeah, we can always pass output if we want to. If there's another program that maybe needs this equation, then maybe it might make sense to pass that as output. But in our case here, we don't really need anything for input or output from the outside world. Okay, so we really just want to focus in on this part here, the actual process, the displaying of the menu request, and displaying the results. That's what main should do. All right, now, the first thing we want to focus in on, okay, inside of main, is figuring out, what is it that main needs to do? Well, first of all, before we can do anything, okay, we need to come up with what is the input needed for this particular program, right? What is it that we need for this particular program to do something? Okay, and that's the actual input, and that's what we're getting ready to define. So that's why for pseudocode, I kind of like to make a reminder to myself here that we're looking, we initially, every program, every function starts with input. You have to have input. So the question is, how can we get this input from the user? What is it that exactly that we want to use for input here? And the answer is, if we look at the requirements, they want us to create a menu module. So we want to call this menu module that, again, anytime we call a function, anytime we execute a program, okay, you're always going to have input, process, and output for every single modular function that you're going to call. Okay, so we're going to really get in this mindset of this is a function. We need to have input, process, and output associated with that function. If you look at the menu module, okay, we're going to call this menu module, we don't really need any input from the outside world to go to this menu module, right? The actual menu module we're going to hard code the menu inside of this menu module. So we don't really need any input from the outside world. As far as the process, what is this guy actually going to do for us? We're going to display a menu and obtain the menu selection from the user. That's kind of the whole point of this particular method called menu, is to display the menu and get the menu selection from the user. Once we've done that, right, now all of a sudden we may have output, and the output of this menu module should be the exact menu item that is selected by the user. Okay, so the whole point of this menu module is displaying a menu and then outputting or returning the actual menu item selected by the user. Okay, we have to start to think like a computer. Okay, and that's why we need to practice the pseudocode, is we need to really realize what is going on with each one of these modules or functions. What kind of input does each one of these modules need? What's the actual process that's being performed? And then finally, what is the output that this actual modular function returns? Okay, so that's the first thing we want to do. We want to call the menu module so that we can process and output the actual item selected by the user. Now here's a step that a lot of people forget, is after you call a particular module, a lot of people forget that you need to store off this output that menu returns in some cases. And we're going to talk about that in a second. There's some cases where we need to actually declare a variable to actually store the output that's returned. There's other cases where we use something called pass by reference, where we don't have to store those results, because inherently when you pass something by reference you can manipulate it. That's in the next video. Okay, this video right now I want us to concentrate at a high level, okay, at a pseudocode level. What is it exactly we're doing? I'm not even worried about implementation. I'm not worried about what's the return value. I'm not worried about pass by reference. All I'm worried about is what is the input, process, and output needed in order to get this this particular program to work. Okay, so after we call the menu module, we know, or we should know, the which menu item it is that the user actually wants. Okay, so that was kind of the whole point of calling that particular module. Now the next step, okay, is, well, that's fine and dandy. We know which operation you want to do, right? That's what menu is being displayed. You know, would you like to add, subtract, multiply, or divide? So the user is actually going to select one of these main things: add, subtract, multiply, or divide. Now the question is, well, we also need the actual fractional values that we're going to perform this operation on, right? What's the numerator? What's the denominator, right? What's the second numerator? What's the second denominator? Okay, so we're actually, anytime you hear that in your head, I'm hoping that you see that anytime what you want to do is going to involve basically more than one line of code, that should say to you want to call a module. You don't want to put all of that all of those procedures into one big main function. You actually want to call a module. So that's why you're seeing call the input fraction values from user module here, is because we want these fractional values from the user, and we should probably break that out into another module. So we're going to call this module, and do we need to provide any input to this module? Is there any input from the outside world that we need for this input fraction values from user? And the answer is no, right? The input that we're getting is directly from the user. That's part of the process, is we're going to ask the user, please enter in num1, please enter in num2, right? Please enter in denominator 1, please enter in denominator 2. So we don't really need any input from the outside world. Now the question is, do we have any output? And the answer is, you betcha. That's the whole point of this input fraction values from user, is to provide these new fractional values that the user put in. So we do have output. We don't really have a need for input, but we do have a need for output for this particular module here. Okay, so again, it took me about 2 hours, okay, to really put together this pseudocode well. Okay, this is not a quick process, and I want everybody who's listening to this, I'm hoping that registers with you. Okay, designing software, you really, you will get better with it at time. It will, you will become more efficient at it. But when you first put it together, you really want to think about each one of these modules. You really want to think about what's the input, process, and output. And you're going to see later on in the third video, I'm going to show you how to actually write unit tests, okay, for each one of these functions. And you're going to see there's a reason why we really need to focus on input, process, and output. Okay, it has to do with testability and maintainability. Okay, we're not just doing this to make things complicated. All right, so really try to think in terms of modules and what input, process, and output each module does. All right, once we do that, we're going to store off the input fraction values from user. Okay, fair enough. So in theory, we're done with the input portion of main. We've got the operation that we want with this guy. We've got the fractional values from the user, right? From the input fractional values from user module, and that should provide all the input that we need to the main module, right? So notice that every method has input that we need to worry about, process, output. Now we need to worry about the main functions process. What is it that the main function needs to do? And this is where things get fun. All right, so if we're going to define the process for the main function here, what you're going to see is, what's the main process? Well, if the menu selection is add fractions, right, we're going to present them with a menu. Do you want to 1, add fractions, 2, subtract, 3, multiply, divide? What we basically want to do is look at this menu output, right, the exact menu item selected by user, if it's add fractions or a representation of add fractions, right, it doesn't actually have to be the string add fractions, it could be a numeric representation of add fractions, then we want to call the add fractions module. Again, anything that takes more than one line of code, we want to turn it into a module. In this case, the requirements want us to turn it into the add fractions module. Now, one of the things we need to think about is what is the particular input, process, and output of, right, this new add fractions module. And you're going to see that for add fractions, we want basically the input is, well, what's your numerator, right? What's your two numerators of the fractions that you're trying to add? What are the two denominators of the fractions that you're trying to add? That's the input that we need to this particular module. Without that input, there's not a whole lot of adding of fractions that we can do there. So we need to make sure that we at least have that input. Process, well, the process is kind of given, right? We're adding the fractions. So the whole point of this module is to do nothing more than take all of these numerators and denominators and add them together in the appropriate way, right? There's certain rules about fractions that we have to follow, like when you add, you have to find a common denominator, right, and things like that. So add the fractional values is very general, but it's describing what this module needs to do. Finally, once we do the process correctly, we should have output, and that's the actual results of the operation, right? What's the actual numerator result? What's the actual denominator result that occurs once you add the fractions together? Okay, so really, again, we're thinking along the lines of what's the module that needs to be called, and what's the input, process, and output of that particular module. Now, once this returns, right, once we're done calling add fractions and we have this output here, again, a lot of new programmers skip this step. You need to store the results of that operation. Whatever this function returns, sometimes, if we're not using paths by reference, we need to store the results of the operation. Okay, so always just kind of put that in the back of your head that after you call a function, okay, make sure to kind of store off the results of that particular function or operation. And we're going to talk about the implementation of that in the second video. All right, so we've done the adding. Well, guess what? You're going to see a similar pseudocode format here for the subtraction of fractions, right? If the menu selection is subtract fractions, we're going to call another module called subtract fractions. Very similar input. You need the fractional values. Process is a little bit different. We need to subtract the fractional values. There may be a different set of steps that we need to do to subtract fractions. And finally, we need to output the actual results. Once we have the result of the fractional operations, we have a resultant numerator, a resultant denominator, and we're going to output those. Again, once we output those, make sure to store the results of the operation. And basically the same thing for, let's see here, multiply and divide in the division of fractions. Let me go ahead and show you what that is. Okay, if the menu selection is the multiply fractions, let me see if I can get rid of this guy here. There we go. If we want to multiply fractions, obviously we're going to call the multiply fractions module. Input is identical. We still need these 4 pieces of information from the fractions to do anything, right? To multiply, input, we need those. The processes, we're going to multiply them. The output is the results. What's the final result? What's the numerator of your result, and what's the denominator? Finally, the same thing for divide fractions. We want to call the divide fractions module. We have the same input, and we have basically the same output. Okay, just make sure you store your results after each operation, or after the selected operation occurs. Where it's not like we're going to do all 4 of these operations at the same time. It's going to be one of these particular operations. And then lastly, I did add add a loop to my main code. Why did I add a loop? Because it's menu driven, right? Anytime we have a menu driven application, we're going to want to basically loop until the actual menu selection is quit. Okay, that's kind of half the reason we have a menu driven application, is so that we can continuously run it over and over again with different input and get different outputs. So let me go ahead and anytime you do a loop, you got to define the start of the loop, which is here, right? And you have to define the end of the loop. So we're basically saying that everything in between this loop here, all the way down to the end loop, is basically going to occur over and over again until the menu selection is quit, and we're finally going to jump out and say, okay, we're done. Okay, so, okay, one little important piece that I almost forgot. So we have input, we have process. Oh yeah, don't we need output? You betcha. We need some output here, otherwise it's not a very useful program, right? So let's come over here, and inside the loop, right, inside the loop, we want to make sure that we have output as well. Now for output, we're gonna use another modular function called output results. And for output results, you're gonna see that there's quite a bit of input that the output results need. And that's basically all of the numerators, all of the denominators, the result numerator, the resultant denominator. We need all of that as input to the function. Now I know a lot of beginning programmers like to put all of this stuff in nice global variables, so they don't have to pass all of these things as input parameters. I can't caution enough how bad global variables are. Okay. In the short term, it may seem like you're doing a good thing and you're cutting down on your workload and makes things less complicated. In the long term, it drastically reduces the testability and maintainability of the code. Do not use global variables, please, ever. Okay, there may be a couple times when global variables are a good idea, but it's almost never. Okay, so for everything that we've seen, even in class, we've never needed global variables. Please stay away from global variables. I can't stress that enough. You always want to use input to functions or parameters instead of global variables. Just because it looks like a lot of input does not mean that it's a bad thing. Okay, so please keep that in mind. All right, so we're going to call the output results. We're passing in the input needed. The process is we're going to do nothing more than display the actual fractional values in equation form. And the output, now this is a little misleading, right? It says output results and the output is none. This is the output to the outside world, right? Do any other functions need to know about the output that we're displaying with this function? And the answer is no, right? Okay, the whole point of this function is to display the results to the user. Any functions outside of this particular function really could care less about the fractional values in equation form. So that's why it says output none. Anytime you're thinking input and output to functions, think about from the outside world. Okay, don't think about input and output needed from the user. Think about from the outside world. The outside world being from outside of this function. Okay, is there any output that may be useful to other functions outside of this function? And the answer is no. All right, so with that said, that's pretty much the pseudocode for the main function here. Okay, as we've defined our input up here to actually grab the operation and the input values from the user. We've defined our process here, which actually says, hey, which one of these particular operations are you interested in? Okay, add, multiply, divide, or subtract. And then once we've selected our operation and we've performed the operation, we're going to say, okay, what output? What are we going to do for output? Right? So we're constantly doing input, process, output, input, process, output. Okay? All right, now with that said, we've got our main function defined, but guess what? There's a whole bunch of other functions that we also need to define. The first one being this menu module. Okay, we need to create a module called menu that basically takes no input, that displays a menu and obtains a menu selection from the user, and then actually outputs the particular menu item selected from the user. So, how do we do that? Basically what I did was, okay, let's see here. Basically what I did was I just copied the pseudocode directly from that main module there, and pretty much just copied and pasted it below just to give you a feel, and said, hey, we need this new guy called menu module that displays the main menu and obtains a menu selection from the user. I transferred directly from up above, input none, the actual process, what it does, and the output. And I would say whenever you need to create a new module, just go ahead and declare it as void. Don't even worry about all of, well, what return type is it, what, all that kind of stuff. Okay, so once we have basically copied what we needed from up above, letting us know what the input, process, and output for this main menu module is, we've declared the actual module just using a void return parameter. I don't want to worry about any of the implementation. We're going to worry about that in the next tutorial video. So now the question is, from a pseudocode, from a design standpoint, what is it exactly that we want this menu function to do? And it's pretty simplistic, really. Basically, we want to input the main thing is we want to provide input to the user, the menu, and say, you know, please make a selection. Welcome to the fraction calculator app. Please choose one of these five main things: add, subtract, multiply, divide. Then once we prompt the user what it is we want, we're actually going to input the menu selection from the user. Okay, and again, we have to think like a computer, right? Very logically, you prompt the user, and then you actually input the menu selection from the user in order to put it in memory. Once we do that, we are then going to basically output or return whatever it is that the user wants. Okay, so input is the menu and then grabbing the actual menu selection from the user. Process is validating that actual menu selection. What if the user put in 7 or 8? What if the user put in -1, right? We better make sure that it is a valid menu selection. And then once we make sure that it's a valid menu selection, we'll go ahead and return that particular menu selection from the function. And we'll talk about implementation in the next video. All right, what are some other modules or functions that we need? You're going to see that we need as well an add fraction module. Okay. Okay. Now that we've created the menu function, we need to look at the pseudocode for the add fractions function. And you're going to see that I basically just copied and pasted the input, process, and output that we defined up here, right, in our main module here. Call the add fractions module, input, process, output. I've copied that directly down here. I've given it a description saying that we basically want to add two fractions together using the input provided. And just to kind of recap, the input needed for this function are the actual fractional values themselves. The process is to add those fractional values, and the output is the actual resultant numerator and denominator. So what is it that add fractions needs to do? We just need to add the numerators together. How do we do that? It's basically, we're basically taking the numerator of fraction 1 for the resultant numerator and multiplying that times the denominator of fraction 2. And that's in order to get the the common denominator. Same with numerator 2. We're taking that and multiplying it times denominator 1. We take the results of that, add them together, and that gives us what's going to be the resultant numerator. For the denominator, the only thing you need to do is actually multiply the two denominators together. For example, if we have something like, let's say, 1/2 plus, let's say, 1/4, right? If we apply this logic, that would be 1 times 4 for the numerator, which is 4, plus, let's see here, 1 times 2, which is 2, and divided by 8, that's equal to 6/8, or, you know, if you reduce it all the way, 2/3, right? 1/2 plus 1/4, or excuse me, 2/4, 3/4, 3/4 there. But, you know, the requirements state that we don't need to give it in the lowest term. So even if we just stated this as our answer, we would be fine, and that's actually what we are going to do there. So I just wanted to make sure everybody was aware of how that resultant denominator works. Okay, and these are all kind of rules established in mathematics. Okay, I'm trying to teach you how to implement the mathematics in code. All right, so this is the pseudocode for add fractions. You'll see that the pseudocode for subtract fractions is very similar, right? Here's a subtract fraction module. We want to subtract two fractions. The input is the actual numerator and denominator is used. The processes that we want to subtract the actual fractional values given, and then we finally want to return the results. Now, how do we do that? Again, take numerator 1 and multiply it times denominator 2. For the second fraction, take numerator 2 and multiply it times denominator 1, and we're going to subtract those two. That's our resultant numerator. The actual denominator is going to be nothing more than the denominator 1 times denominator 2, and then we're going to return the actual result numerator and denominator. And I'm going to go over the implementation for this in the second video. For multiplication, a little bit different. Okay, multiplication. In order to multiply a fractional module, it's actually really easy, right? You just take numerator 1 times the second numerator, numerator 2. For the denominator, you're just taking the two denominators, multiplying them together. So multiplying fractions is actually one of the easiest operations. To divide, if we want to divide the actual fractions. And if I'm going a little fast, please feel free to pause the video and really look at the pseudocode to understand it, because the key to having good code is a good design, right? And the key to having a good design is, at least at a minimum, good pseudocode. For the fractional module, right, we're going to take in the same numerator and denominators needed. We're going to divide the fractional values by multiplying by the reciprocal, which you'll see in a second. And we basically just return, right, the resultant numerator and the resultant denominator as the output of this modular function. So how do we divide fractions? We basically want to multiply, well, let's perform the division operation, which this is where we do the reciprocal, right? So for the numerator, right, we're actually going to take numerator 1 and multiply it times denominator 2, right? And for the resultant denominator, we're going to do the same thing and kind of multiply across from each other and do the whole reciprocal thing. And that's going to be our answer. The numerator is going to be numerator 1 times denominator 2, and the denominator, the resultant denominator, is going to be denominator 1 times numerator 2, and then we're finally going to return those values. So that's how we divide fractions. two more methods left if we want to look at, let's see here, if we want to look at our output results module, right? And again, I basically just grabbed what was up above for the input, process, and output. The input to the output results, we need basically all of the fractional values, everything from all the numerators, all the denominators, all the resultant numerators and denominators. And additionally, we also need the operation being performed. If we're going to show all of these numbers in equation form, you're going to see that we're going to have a nice big if operation asking which operation was used so that we can change, right, each one of these operators in the middle. Are we doing addition? Are we doing subtraction? Are we doing multiplication? Are we doing division? That all depends on this seventh operation getting passed in, telling us which operation was actually used. The process is nothing more than we're just displaying the fractional values in equation form, right? We're just doing a big cout statement where we're concatenating a big string with all of the different fractional values, and that's that. Then we're actually going to display the fractional values once we concatenate everything together. So output to the outside world, to other functions outside of this, we don't really need to pass anything. We don't need to return anything because there's nothing that the outside world or the outside functions need or don't already know about, right? There's nothing unique inside of output results that other functions outside of this need to know about. So you're going to see that there's no real output needed by this particular method or module. And then last but not least, we have our what we called, I want to say it is the input fractional values from user, right? Where we don't really have any input per se from the outside world because we're getting them directly from the user, right? If you read the process definition, input fractional values directly from user, okay? Then as output, that's kind of the whole point of this function, right? Is to grab values directly from the user and then pass them back, right? Pass them back to the outside world, pass them back to the functions that want to use these values. So there is output, but we don't really have any input. As far as what is this method doing, we just want to prompt for the first numerator, right? And then input the first numerator. Rinse, wash, and repeat here. Second numerator, first denominator, right? We're basically prompting and inputting, prompting and inputting. When we're finally all done with the prompting and inputting, we're going to return all four of these particular values so that we can use them. Okay, so with that said, that's pretty much everything from a pseudocode standpoint of what the fractional calculator needs to do. In my next video, I'm actually going to walk you through how this pseudocode translates directly to C++ and show you the direct correlation between the two. So we'll talk more about that then. Thank you very much, and please watch my next video where we'll talk about the implementation.